I'm Susie Newhan, and this is the first video in a series on basic linear functions. This one's about how to plot a simple function. So what do we mean by a linear function? We simply mean one that plots to a straight line. So we're going to look at an example of that today, and we're going to learn how to plot it ourselves. So let's give this a name. Let's say it is y equals 2x plus 3. Now you remember a lot of this from school. The problem with that is that it doesn't look like an economics function, does it? So let's make it look like an economics function. So here, price is dependent on quantity. That looks better, doesn't it? Now we see that if we know the value of Q, we can find a value of P. So we say that P is dependent on Q. If we're given the value of P, we can also find the value of Q, but it's not so easy, is it? This is like a recipe for P, the way it's written at the moment. Nice and easy. If we know Q, we know P. And indeed, we can work out all the values of P ourselves from values of Q and plot our own graph. So let's do that. Let's get rid of this one. And let's explore what happens to P at various levels of Q. So what about when Q equals 0, P equals what? Well, P is going to equal to 2 times 0 plus 3. Now, why did I write 2 times 0? That's because in algebra, if two things are written next to each other, it's always 2 times Q. There's always an invisible multiplication there. And 2 times 0 is 0, plus 3 is 3. So let's continue. What if Q is 1? P equals 2 times 1 plus 3. 2 plus 3 is 5. Q equals 2, P equals 2 times 2 plus 3 equals 7. Q equals 3, P equals 2 times 3 plus 3 equals 9. And hopefully you can see that each time the value of Q changed. Now, often we put this into a little handy-dandy table, and let's do that now. QP, in fact, you'll see a worksheet. Worksheet number 1 for the first lecture is asking you to fill in a grid like this. So let's pick the values of Q that we're interested in and put in the corresponding values of P. So we've got 3, 5, 7, 9. So we've got all we need to plot that graph. Now, this is Q and this is P. Remember, at school it was usually Y there and X there, but now P is really taking the place of Y. So the dependent variable is normally put on the vertical axis, and the independent variable, the one that does its own thing, and then creates a value of P. That one goes on the horizontal axis. So here's our table. We can now plot it. So these are all the Q values, what you'd normally think of as the X values. So when Q is 0, P is 3. When Q is 1, P is 5. When Q is 2, it's 7 and 3. Da-da-da. And there's our straight line. So just a little bit more notation, because this is our first video. What we have here is P is a function of Q. So this tells us that this relies on the value of Q. So we can put any value in there and we'll get a value for P. Now later on in your economics, you will have functions of more than one variable. Here's one that you will definitely see. You'll see it in my module, and you'll certainly see it in other modules, where output of a company is a function of capital and labour. We have to look at values of capital and labour to determine the output, but that's so much later. At the moment, we're just looking at functions that are functions of just one variable. So let's give before we finish, let's give this a name. We're going to call it a supply function. And here's a definition of my supply function. So this might be looking at the economy as a whole. Collectively, we're looking at suppliers as a bunch, and we are using this function to predict at a particular level of output, say 3 million, what price we would expect to see in the market. To make this correct, it really ought to be the minimum price that would persuade suppliers to produce that much.